All right, welcome back. So this time we're going to go over Amazon S3. Why? Because S3 is going to be your primary storage service. So before we get started, remember to like, subscribe, and share this with anyone you know who's going to be taking the AWS Machine Learning Associate. All right, let's go with S3 fundamentals. All right, let's open this up and you should see this. All right, so S3, which is simple storage service, provides virtually unlimited object storage with industry-leading durability. It's 99.999999999% reliable and durable, right? Basically the 11 nines. And it's variable with availability depending on storage class. S3 organizes data into buckets, which are top-level containers that must have globally unique names across all AWS accounts and regions. Within the buckets, objects are stored with unique keys representing the full path to the file. The service appears global, but buckets are created in specific regions, which is crucial for data residency requirements and latency optimization. S3 supports objects up to 5 terabytes in size, with multi-part upload required for files exceeding 5 gigabytes. Objects can include metadata, tags for store organizations and lifecycle management, and version IDs when versioning is enabled. So let's go into storage classes and optimization. All right. All right. This should be good. Okay. So where we got? S3 standard. This provides immediate access, low latency for frequently accessed data. It supports 99.99% availability and sustaining 2 facility failures. This class suits big data analytics, mobile applications, gaming, and content distribution scenarios. Then you have S3 standard IA. All right. That's this one right here. Okay, so this is infrequent access. This offers lower storage costs, but charges for retrieval, providing 99.9% availability. It's easier for disaster recovery and backup scenarios where data is accessed less frequently, but needs rapid access when required. Then you have S3 One Zone IA. All right, so this stores data in single availability zones, right? It offers 99.5% availability with even lower costs. This class works well for secondary backup copies or recreatable data where the risk of availability zone failure is acceptable. And then you have the Glacier classes over here. All right. So there's Glacier Instant Retrieval, which enables millisecond access for quarterly access data with a 90-day minimum storage. Then you have Glacier Flexible Retrieval, which offers 3 retrieval options. One is expedited in 1 to 5 minutes. 2 is standard in 3 to 5 hours, or bulk, which is available in 5 to 12 hours with a 90-day minimum. Then you have Glacier Deep Archive, which provides the lowest cost storage for long-term retention with 12 to 48-hour retrieval times and 180-day minimum storage. And then let's go back over here. You'll see intelligent tiering. Secret, nobody really uses this. They usually set up their own tiering. Anyways, intelligent tiering automatically moves objects between access tiers based on usage patterns, and it eliminates the need for manual lifecycle management while optimizing costs. So let's go into a little more about lifecycle management. All right. All right, let's go over here. Okay, so S3 lifecycle rules automate transitions between storage classes based on object age and access patterns. Transition actions move objects to more cost-effective storage classes over time, while expiration actions delete objects or versions after specified periods. Rules can target specific prefixes or object tags, enabling fine-grained control over data management, meaning you can get better management and you know it's actually being managed, right? For AI and machine learning applications, lifecycle rules help manage training data costs by moving older data sets to cheaper storage while keeping current data readily accessible. They also help manage model artifacts and experimental data by automatically cleaning up temporary files. So what's the purpose? This is for infinitely scalable object storage services that serves as the backbone for any or many AWS services and machine workflows. So what are the key characteristics? The global namespace. The bucket names must be globally unique. Regional service. Buckets are created in specific regions for data residency. And then the 11 nines for durability. So 99.99999999999% durable. And it supports virtually unlimited storage capacity. All right. So what are some security features? Let's go over here. This is B security. Okay. So you have several encryption options. You have server-side encryption options that include S3, or I'm sorry, SSE, S3. Boom. All right. SC, SS3, or SSE, S3, excuse me, which is server-side encryption. All right. So this is managed keys with AES 256 encryption, and it's enabled by default. Then you have SSE KMS, which is the customer managed keys through AWS Key Management Service, KMS, and it provides users control and CloudTrail logging, but with potential API rate limiting considerations. Then you have SSE C. This is the customer provided keys where AWS never stores encryption key, requiring HTTPS for all requests. And finally, you have DSSE KMS, which is dual layer encryption for highly regulated environments requiring CNSA compliance. Then there's client side encryption. All right, what is that? This requires applications to encrypt data before uploading to S3 with complete customer control over keys and encryption processes. Then you have encryption in transit. This uses HTTPS endpoints to secure data transmission with bucket policies available to enforce encrypted connections by denying requests using HTTP. Next, you have access control. Let's go over here. All right. Control. All right. This will be a video. Not great, but you can see where this is and you can store this. All right. This is always good. And the AWS reInvent series has a lot of this. So let's go into the basic one. So IAM policies control user-based access through identity-based permissions attached to users, groups, or roles. Bucket policies provide resource-based access control, enabling cross-account access and public access scenarios. And then access control lists offer object-level permissions, but are less commonly used in modern implementations. Then you have S3 access points. These simplify security management for complex access scenarios by creating dedicated endpoints with specific policies. Each access point has its own DNS name and can be configured for internet or VPC access, enabling fine-grained access control without complex bucket policies. Then you have S3 Object Lambda, which enables real-time data transformation without duplicating objects, allowing different applications to access modified versions of the same data through Lambda functions that process objects during retrieval. Then you have block public access settings. All right. So AWS provides block public access settings as an additional security layer to prevent data leaks. These settings can be applied at the account or bucket level, overriding any bucket policies that would make objects public. This feature provides protection against accidental public exposure of sensitive data. All right. So let's go over, lifecycle management. All right. So then first you have S3 versioning. All right. Oh no. S3 versioning. All right, let's go. So versioning. Okay, here we go. Let's go into this. All right, so S3 versioning. Versioning protects against accidental deletions and enables rollback capabilities by maintaining multiple versions of objects. When enabled, S3 creates new versions rather than overwriting existing objects. Deleting versioned objects creates delete markers rather than permanent deletions, allowing for recovery of previous versions. Then you have S3 replication. So cross-region replication, CRR, enables compliance, disaster recovery, and reduced latency access by replicating objects to different regions. Same region replication, SRR, supports log aggregation and live replication between production and test environments within the same region. Replication requires versioning on both source and destination buckets and appropriate IAM permissions for the S3 service. Only new objects are automatically replicated. Existing objects require S3 batch replication. Delete markers can be replicated optionally, but permanent deletions, specific version deletions, are not replicated to prevent malicious deletions. Then you have performance optimization. All right, so let's see if we can find some article on this. All right. Okay. All right. So S3 automatically scales to support very high request rates with 100 to 200 millisecond first byte latency. The service supports 3,500 put, copy, post, delete requests per second per prefix and 5,500 get head requests per second per prefix. Since there's no limit to prefix numbers, performance can scale virtually infinitely by distributing requests across multiple prefixes. Then there's multi-part upload. All right. So multi-part upload is for files over 100 megabytes, multi-part upload is recommended, and it's required for files over 5 gigabytes. This technique parallelizes uploads by dividing large files into smaller chunks uploaded simultaneously, maximizing bandwidth utilization and providing better error recovery for failed uploads. Then you have transfer acceleration. All right. So S3 transfer acceleration uses CloudFront edge locations to optimize global data transfers. Data uploads to nearby edge locations before being transferred to the target S3 bucket over AWS's optimized network infrastructure. So it reduces transfer times for globally distributed users. Then you have byte range fetches. For downloads, byte range fetches enable parallel retrieval of specific file portions, speeding up large file downloads and providing better failure resilience. This technique is particularly useful for applications that only need specific portions of large files, such as reading file headers or extracting specific data ranges. Then you have event notifications. S3 can automatically trigger responses to bucket events such as object creation, deletion, or restoration. Events can be filtered by object prefix or suffix and sent to multiple destinations, including SNS topics, SQS queues, and Lambda functions. For more advanced scenarios, Event Bridge integration provides access to over 18 AWS services as destinations with sophisticated filtering capabilities. Event notifications enable automated workflows like image thumbnail generation, data processing pipelines, and real-time analytics. They're crucial for building responsive, event-driven architectures that can process data as soon as it arrives in S3. Then, native SageMaker integration. All right, so now we're getting towards the ML portion of it. All right, S3 integrates seamlessly with SageMaker for all phases of the machine learning lifecycle. Training jobs can directly access datasets stored in S3, while model artifacts are automatically stored back to S3. This integration supports distributed training scenarios where multiple instances need concurrent access to large datasets. Data processing pipeline integration. So S3 works with various AWS data processing services, including Glue for ETL or extract, transform, load operations, Athena for serverless querying, EMR for big data processing for medical records, and Lambda for serverless compute. This ecosystem enables comprehensive data processing pipelines that can prepare raw data for machine learning applications. Then feature store integration. So S3 can serve as the underlying storage for feature stores, providing durable storage for feature sets used across multiple machine learning models. This service's scalability and performance characteristics support both batch feature generation and real-time feature serving scenarios. Then you have storage cost optimization. Implementing appropriate storage classes based on access patterns significantly reduces costs. Using intelligent tiering for unpredictable access patterns automates optimization without manual management. Lifecycle policies can help transition data to cheaper storage classes over time while automatically cleaning up unnecessary data. And transfer cost management. So understanding data transfer costs, particularly for cross-region transfers and external data egress, helps optimize architecture decisions. So using CloudFront for content delivery can reduce transfer costs for frequently accessed data. Planning for data locality by placing compute resources in the same region as data storage minimizes transfer charges. So let's give you a show of what it looks like to create a bucket. All right, so we're going to go to a console, click S3. All right. And then we're going to click create bucket. All right. So we're going to choose a unique name. So let's call it DevOps ML test bucket. All right. So then we're going to go down to the ownership, ACLs. All right. So ACLs are disabled. This is good. So this means that all objects in this bucket are owned by this account. Access to this bucket and its objects are specified using only these policies. All right. And these are enforced. And then public access, we're going to keep that blocked. So blocking all public access by default, right? So it blocks access to buckets and objects granted, access to buckets and objects granted through any access ACLs, blocks public access to objects granted through new public bucket or access point policies and blocks public and cross-account access to buckets and objects through any. So this is going to be limited to this account. And then you're going to see versioning. Do we need this? Not really, but we'll click enable. Then we'll click disable. And then you can do tags, right? Tags are good, like we talked about, for object and management level storage and monitoring and basically finding what you're doing. All right. And then your encryption type. So we'll do the standard server-side encryption. That's all we'll need for this. Bucket key, we'll have this enabled. And then click create. All right. So this is the bucket created today. All right. So at this point, if we wanted to do machine learning, we could configure this by selecting this, clicking upload. We can drag and drop. We can click add file, add folder, and then we can configure the storage class and encryption, set some metadata tags. So let's go back over here. Metadata tags over here, right? Isn't this it? No, that's just metadata. Properties. Yeah, there we go. Tags. So you can add tags here to be able to track this. If you're using this for a project, is this for a certain purpose, certain environment, so on and so on. All right. Then we can go over the management for the lifecycle rules. We can create lifecycle rules here. All right. And we can set this for, we can just create the name. What the scope, does it apply to one or two filtered items or to all objects? And enter the prefix, add tags for this, specify the minimum object size, maximum, lifecycle rules, and then click create the rule. All right. We're going to go back out. And then we're going to see event notifications. So properties. All right. So for event notifications, let's see. Okay. So event bridge, right? Go in here, event notifications. What's the event name? Enter that. What's the prefix? See, images is a good one. Suffix you could do by JPG, JPEG, .gif. There's a bunch of different types, right? And you could choose what are the event types: object creation, object removal, restoring an object, ACLs. You can keep going down the list: lifecycle rules, intelligent tiering, all this stuff. And then what's the destination? All right. So you can choose a Lambda function for a script based off of this event. If something gets dropped in this bucket, you can have an event notification to transform it using a script that you created. You can have an SNS topic for notification, right? Or you can have an SQS queue to be read by the server. And then you can choose a special Lambda function or enter it by ARN, save the changes, and you're good to go. All right. So the basic setup for this, go to the S3 servers in the console, which you've done. You create the bucket, provide the globally unique name with the naming convention. You want to go for lowercase, no spaces. And it's about 3 to 60-ish characters. All right. And then you configure the region, which we did. Well, we defaulted to US East 1. That's okay. And then security settings, we went over that for blocking public access. And then advanced settings for lifecycle rules, replication, event notification. We reviewed that. All right. And then we went over the management of the object access, right? So you talk about that with the ACLs, the bucket policies, and then you could add on some extra stuff with metrics, right? So you can start measuring the metrics here, storage class analysis, and you can start creating this to go to CloudWatch metrics and monitor request patterns, error rates, and storage utilization. And you can do the cost right here with this as well. So you can review the breakdown by storage class and implement some lifecycle policies to optimize costs, right? So the best practices for this is to use meaningful prefixes and folder structures, right? Because when you're in here, you want to have, let's say, a folder, images, right? Or videos, all right? And it can't contain this slash, it'll be created, right? But it can do things based off the folder structure. Then you can do a batch operations with this based off of anything in the folder for images or videos or audio or whatever you have. Finally, you have your security for the encryption, your monitoring using CloudTrail, and your cost management using those lifecycle rules. So this would be one of the primary uses for storage in the cloud. You do have other options, which I'll go over briefly, but this would be the main one. The other three FSX for Lustre. This is the fastest, but it costs the most. It's good for high performance training and large data sets. Number two is EFS. That's the file storage. The training speed is moderate. It's slower than FSX, and then the cost is medium. It's more expensive than S3, and it's good for shared data sets and collaborative development. The third one is EBS, that's block storage. That is faster than EFS, but slower than FSX for Lustre. The cost is about the same as EFS, but this is good for single instance training and persistent storage. And then finally, what we've already reviewed, which is the fourth one, is S3. This is the slowest training speed, but it is the lowest cost. This is good for data lakes, archiving, and batch processing. So going forward in these lessons, you'll find that S3, EFS, and FSX for Lustre are best for SageMaker native integration. And they're good because they have direct input modes. Well, your basic look is for what is going to be best for performance, shared access, single instance, or persistent storage, cost effectiveness for large scale, and then archiving and compliance. And S3 is pretty much the bus for some of them, not most of them. All right. And then remember a couple of things for the exam. The main file types you'll probably see for your data would be CSVs, comma separated values. These would be human readable, simple, row-based. JSONs, which would be semi-structured. These will have a flexible schema with key value pairs. And then you'll have Avro, which is a binary schema evolution. It's row-based. And Parquet, which is a columnar, analytics optimized, efficient compression storage method. All right. I would say the next things you need to look at are EBS and your volumes for it. So let's go over that pretty quickly. Okay. Let me see. All right. Give me a second. All right. Let's see if we can find this here. EBS block. Okay, so block storage. Okay, you'll find this here. Okay, so EBS is a block storage service designed for use with Amazon EC2. So it's used as a primary storage option when provisioning compute infrastructure on AWS, and it supports a wide range of machine learning and performance workloads. But unlike object storage like S3, EBS acts more like a traditional hard drive or SSD, making it ideal for storing data sets, software environments, model artifacts, or logs that are accessed through file systems. So EBS provides persistent high-performance block storage that are tightly integrated with EC2. So it persists beyond the lifecycle of the EC2. You can detach and reattach volumes to different instances within the same availability zone, and it can be provisioned for specific performance goals like IOPS or throughput. For machine learning workloads, EBS is useful for training or inference tasks that require fast disk access, caching, or when you need reproducibility through snapshot-based backups. All right, so there's volume types, and let me see if we can go in here. All right, so there's a variety of volume types, and these reflect different performance profiles and cost structures, and it's designed to optimize various computational workloads. So for machine learning applications, understanding these characteristics enables informed decisions about storage configurations that balance performance requirements with cost considerations. All right, first you have general purpose. So these would be the GPs, right? These are the default choice for most machine learning workloads because they're balanced performance characteristics and cost effectiveness. These volumes provide up to 16,000 IOPS and 1,000 megabits per second throughput, with the ability to independently configure IOPS and throughput separate from storage capacity. This flexibility makes GP3 volumes ideal for training, data storage, model artifact caching, and general purpose machine learning development environments where consistent performance is needed without the premium cost of specialized volume types. Then you have provisioned IOPS SSD, right? So these cater to high performance machine learning workloads, and it requires sustained IOPS performance and low latency. So these have capabilities of reaching 64,000 IOPS with sub-millisecond latency. So IO2 volumes excel in scenarios involving large-scale distributed training, real-time interference with frequent model updates, or data-intensive feature engineering pipelines. The guaranteed performance characteristics makes IO2 volumes particularly valuable for production machine learning systems, where performance predictability is essential for meeting your service level requirements. Then you have the throughput optimized volume, which provides cost-effective storage for large sequential data sets common in machine learning pre-processing pipelines. With throughput capabilities of the 500 megabits per second, these volumes are well suited for storing large training data sets, batch processing workloads, and archival storage for historical training data. The sequential access patterns that characterize these workloads aligns well with the performance characteristics of the volumes, making them an economical choice for storage-intensive machine learning operations. And then you have the cold, which offers the most cost-effective storage operation for infrequently accessed machine learning data. These volumes are optimal for storing backup training data sets, completed experiment artifacts, and long-term retention of model versions for compliance or reproducibility requirements. While the performance characteristics limit their use for active training, these volumes provide substantial cost savings for data that requires long-term retention but infrequent access. All right. So let's see. Let's go into so I can talk a little bit about security for this. All right, so this is broader. All right, so data security in machine learning requires comprehensive encryption strategies. So it protects the sensitive data, the model artifacts, and the processing results. So within EBS, encryption capabilities provide multiple layers of protection that integrate seamlessly with AWS KMS, the key management service, and organizational security policies. So one, you have encryption at rest. With EBS, encryption ensures that all data stored on volumes remains protected through industry standard AES 256 encryption. This operates transparently to applications and machine learning frameworks. It requires no code modifications while providing comprehensive data protection. The encryption process uses data encryption keys that are themselves encrypted using customer master keys, managed through the AWS KMS, creating a hierarchical key structure that enables granular access control and audit capabilities. Then you have key management integration. So with AWS KMS, this allows organizations to maintain control over encryption keys while leveraging AWS managed infrastructure for key generation, rotation, and access control for highly regulated machine learning environments. This is for customer managed CMKs that provide control over key policies, enable fine-grained access controls, and only ensures that authorized personnel and systems can access encrypted training data. This also enables audit trails through CloudTrail and tracks the key usage for compliance and security monitoring. Then you have, let me see, gosh. Then you have your encryption in transit, right? So this will deal with the protection ensures that data moving between EC2s and EBS remains encrypted during transmission. So this protection is important for distributed machine learning workloads where training data and model updates flow between multiple instances, as well as for multi-tenant environments where network isolation is critical for maintaining data confidentiality. All right, so let's see. So how does this integrate with AI? So EBS volumes integrate with machine learning and the frameworks, providing persistent storage foundations that enable complex machine learning workflows. And so SageMaker supports EBS volumes for both root volumes on training instances and additional data volumes for large data sets that exceed the capacity constraints of other storage options. And so SageMaker integration will let machine learning engineers specify custom EBS volumes configurations for training jobs, provide control over storage performance characteristics that can impact training times for input-output intense workloads. So the ability to persist data across training runs through EBS volumes, enables iterative development approaches, and supports debugging scenarios where examining results is necessary. Well, sorry. And then you have containers and Kubernetes, right? So this supports persistent volume claims that map to EBS volumes. So it enables stateful machine learning workloads and requires data persistence across container restarts. So this integration is really important for long-running training jobs and inference services that maintain state information or cache data for performance optimization. And you have framework compatibility that ensures that the popular machine learning frameworks like TensorFlow or PyTorch or Scikit can use the EBS storage without modification. And the standard file system interface presented by EBS means that existing machine learning code and training scripts require no changes when migrating from on-prem or other cloud environments. All right, so let's show you to create the volume real quick. All right, so let's choose the volume, GP3, gigabyte size. 8 is a little large. Let's do 20. IOPS, you can use 1,000. Throughput, 125. All right, so then you select the availability zone. This must match the instance, the VM or EC2 that you're using. And you can do a snapshot. I usually like us to, yeah. Well, we don't have to create one from this. So, but you can create a snapshot, refresh this, encrypt it, select the key. We already have a default, or we can specify and create one. Oops. All right. So default. Now we would enter our KMS key yarn here that we've created. All right. Add the tags, and then you click create the volume, and then you can attach this to the target EC2. All right. And then once you're done, you would be able to go in. You can see snapshots. You go to the EC2 instances right here, but we don't have a live instance, right? And then you can see the root and any additional volumes that would be listed here, but we don't have anything running. All right. Okay. So you want to be careful with these because a lot of them are set up to delete automatically once you detach, all right? Once you detach or terminate that instance. So you want to have additional volumes so it can persist. You want to have snapshots so you can make sure that it is persistable. And then you also want to note that this is locked into the availability zone that you created in US East 1, A, B, C, etc. And to move it across availability zones, you want to create a snapshot and then restore it in the target availability zone. All right. But remember, the unattached volumes can exist independently, and they could be useful for pre-provisioned storage, testing, or manual attachment. So remember, these two primaries for EBS are foundational for infrastructure for many AI and machine learning systems. So these offer your persistent, secure, and fast storage to train models, to process data, and reproduce environments. So with these features, it can provide the flexibility and resilience for your AI use cases. And with that, we're done with this chapter on storage. The next one we'll go into is FSX for Lustre. But thank you for joining. Remember to like, subscribe, and share it with anyone you know who's actually going to take the AWS Machine Learning Associate exam. Have a good day.